Hi, this is just going to be a very quick video on using the sketch method plus calculus to find the turning point. So rather than using gsolve to find the turning points, we'll be using calculus, though we'll use gsolve just to confirm and have a look at the values that we're looking for. Okay, so very first thing we'll do here is just transformation, expand. Now, just a hint here, if you type in it as it stands, like that, the x minus 1, when you go OK, it does expand it, but not quite in the way that we want it to do. So actually put in the minus x in brackets, like everything else is in brackets, and that's what we're after. So y is equal to negative x to the 4 plus 2x cubed plus 5x squared minus 6x. Okay, dominant term is negative x to the 4, giving it that shape. The y-intercept is when x equals 0. You must write this when x equals 0. Y equals, and it's pretty easy this one, it's 0, 0, 0, 0. So y is equal to 0, there's nothing left over. The x-intercepts, or zeros, they are when y is equal to 0 and that means you have to solve 0 equals negative x to the 4. The easiest way to do that is to solve it as negative x, use the factorized form, x minus 3, x plus 2, x minus 1, meaning that 0 is equal to either this is 0, or this is 0, or this is 0, or this is 0. So either x equals 0, or 3, or negative 2, or 1. So it goes through there, there, and negative 2 as well. And we know the basic shape, so it's going to go up and down and up and down like that. There we go. Now we've got to use calculus to find the stationary points. So if we'll sketch it anyway and have a look at gsolve just to see what it is that we're aiming for. So here's this function, negative x to the 4 plus 2x cubed plus 5x squared minus 6x. If we sketch it, here we go. Click in the graph, go to analysis gsolve, and if we have a look at the maximum points first, you see there's two of those. There we go. So negative 1.3 and 9, that's what we're aiming for. And there's another one at 2.3 and 9. There's also a minimum point. If we go to analysis gsolve min, oh sorry, did it max again. Analysis gsolve min. There we go, at 0.5 and 1.56 and 1.7. Okay, so in order to use calculus to find the turning points, the first thing we're going to have to do is take our function y equals negative x to the 4 plus 2x cubed plus 5x squared minus 6x and differentiate it. So we'll find dy by dx, which is negative 4x cubed plus 6x squared plus 10x minus 6. You can, of course, use your calculator to do that. Remember, it will differentiate nicely anything that has kind of nice integer values, but for anything that's not so nice, really you want to be differentiating it yourself. Okay, now then, very important, we're trying to find the points here, here and here where the gradient is 0. There's no slope here, here and here. Those are the turning points. So we have to solve, or let dy by dx equal 0. And now this is key, and you must write this as part of your working. So 0 equals negative 4x cubed plus 6x squared plus 10x minus 6. Solve that. It's interactive, advanced solve. We've got 0 equals negative 4x cubed plus 6x squared plus 10x minus 6 And there you go. You can see those values. Those are the x coordinates we found before. So x is equal to negative 1.3, 0.5 and 2.3. Now our y values are going to come from subbing it back into the y equals equation, not dy by dx. Remember, if you sub that in, all you're going to get is 0, or very close to it because we've rounded here. If you want to work out what y is, so we have the x parts of our coordinates here, negative 1.3. We're missing the y part here, and this one is 0.5, and we're missing the y part, and this one is 2.3, and we're missing the y part. Lots of different ways you can work it out. You can sub it in and work it out. You can use your calculator to do that. We've already seen how we can use gsolve to actually find out what those points are. So just to show you the subbing in way, we would then sub x into y equals, it doesn't really matter which form you use, but let's use the factorised one because it would be easier to type into our calculator. So final bit, when x equals negative 1.3, y equals, and you could sub it in here, and we would have negative, and it would be negative 1.3, so that would actually be positive 1.3, and then we'd have negative 1.3 minus 3 multiplied by negative 1.3 plus 2, and then negative 1.3 minus 1, which is 8.999. Remember, it was 9 that we were looking for, so it's slightly different just because we've rounded, but 8.999 or 9 to 1 or 2 or 3 decimal places. So there we go, that one is 9, or rather y is equal to 9, so we get a coordinate minus 1.39, which is a local maximum point. And you can do the same again for the other two if you want to just change those values in here. So you'd have negative 0.5 and positive 0.5 there, and change that to 0.5 and change that to 0.5, and there's our minus 1.5625 that we found before. So when x equals 0.5, y equals negative 1.5625. Oh, sorry, 25. So there's another point there. 0.5, negative 1.5625. And that is a local minimum point. Sorry, just can't quite fit that in there. And that's a local minimum. Look, and you could do the other outer space here, but you could do the same again with this one, and that would be another local maximum point. Okay, well that's it really. It's just really important that you get this line in here as part of your working very, very clear, and that you don't make the mistake of subbing x into the dy by dx when you're trying to find the y coordinates. So you sub it into the y equals equation, or just go back and grab your values from gsolve, because you've shown the working out here as to how you would find it. Okay, that's it. Cheers.